Hello students, welcome to the questionnaire round, and what we are going to discuss is the JEE advanced pattern for IUPAC nomenclature. So just pick up your pens because you need to draw the structures, then find out the names, the IUPAC names of the compounds we are going to discuss. So let us just start off with the first question. What do we have in the first one? So I have got the IUPAC name for the hydrocarbon represented by this swastik sign. So you need to find out the name. Do not get confused via the images. Just you need to have a proper structural formula for this very bond line formula. So let us just form the structural formula. What would it be? For some of you, it may be very simple to recognize what all carbons are there in the bond line formula itself. So you can also number the carbons in the image itself. But let me just break it down first in order to show you what all carbons are represented by this very structure. So I have got here a carbon in the middle, CH2, CH3. That is how the structure has been made. And again CH2, CH3. So this is the kind of structure that we are getting. Now we need to number the carbons, find out the word root. So what it would be? Either it can be this ways or this ways or that ways. So any of them, if you pick any one of the word roots, it would be having similar number of carbon atoms. So it's so simple. So it is, I am choosing this 1, 2, 3, 4 and 5. You can also choose it from here itself. That means 1, 2, 3, 4 and 5. That means I need to choose the pent as the word root. Where is the pent? Here is the pentane as well as here. Now again what I need to see is on to the third carbon I have got 2 ethyls. On to the third carbon I have got 2 ethyls. That means what? I have got the answer 3,3-dimethyl pentane is the answer for this very question. So simple, so easy. So it's 3,3-dimethyl pentane is the answer. I hope everybody has got the answer right. So now let's just try to move on to the next question. What is the next question saying? So it's right. The compound with the molecular formula C6H14 has 2 tertiary carbons. So what are 2 tertiary carbons? A carbon linked with 3 further carbons. So carbon linked with 3 carbons. I've got 1 tertiary carbon and I've got another tertiary carbon. Let us just say this. So all of these carbons will combine to form what? C6H14. That is the question saying. But if you try to count the number of carbons that I have taken over here, these are how many? 8. I need 6 only. That means what can I do over here? I can connect it. I can connect the 2 structures. How? So I can connect these 2 as this. So this would be the compound that is required here in the question. And let me just count the hydrogens. I hope everybody has counted 6, 6, 12 and 13 and 14. So we have got the answer here. That means this is the compound that is required. And also if you notice, the carbons over here are only tertiary. Carbon which is bonded to 3, carbon which is bonded to 3. So now you need to find out the IUPAC name of this compound. So I am going to find out. So let us just have a simpler structure here. So this is the structure. Again I need to find out the word root. So it would be 1, 2, 3, 4. So 2,3-dimethyl butane. So that is the answer. I hope everybody has got it. 2,3-dimethyl butane. That is C is the answer over here. it was also very simple. You just need to have a proper knowledge about what all things are required in the question. That means they had asked about the 2 tertiary carbons having this particular formula. That means this structure C6H14 contains 2 tertiary carbons. We have got 2 tertiary carbons. So you need to first simplify the question, then find out the answer. Now let's have a look at the next question. IUPAC name of the following molecule. Again you need to find out the IUPAC name. So what is it? So if you look very carefully, first of all, what you need to do is, you need to include the double bond in the word root. So I have got choosing the word root. Choose the word root, that is our first thing in the case of IUPAC naming. So the word root will always be containing the double bond. So always try to include unsaturated part in the word root. And you need to number it lowest possible. So lowest possible number will be given to this double bond over here. It would be 1, 2, 3, 4, 5. Again I need to have a longer chain. 6. I can go either this ways or this ways. So I am going this way. 7. So either of the ways I will be getting what? Hept. That means 7 carbon atoms as the word root. So I have got the word root. Now let us just number it. So I have got onto the second carbon as ene. So can you see onto the second carbon as ene? Yes. And here it should be hept because of 7 carbon atoms. So hept to ene. That is our answer, but let us just confirm, is it having the similar kind of substituents or not? On to the 5th I have got methyl. On to the 6th I have got methyl. Is it so? 5,6 dimethyl. That means we have got the correct answer over here. I hope everybody has followed up. So that is the A as the answer. Let's just now take up the next question. Now, which one of the following molecules is S-butyl phenyl vinyl methane? Such a long question. So it's S-butyl phenyl vinyl methane. So if you try to analyze the name itself, S-butyl phenyl vinyl methane. That means what? S stands for here is, so just pay attention, S stands for sec. That means they are telling us about the secondary butyl. Phenyl and then rest of the name. So basically, what are these? These are the substituents over here. Substituent, substituent and substituent. What is the word root? Word root is just for the 1 carbon atom, that is methane. So if I try to just form the formula over here, I'll be then matching up the options. So if I just try to form it, meth, that means 1 carbon atom attached to how many substituents? 1, 2, 3. So it would be sec-butyl first of all and phenyl. So it would be PH for phenyl, and vinyl is something like this. That is vinyl, we already know it. That is phenyl. And I need what? Sec-butyl. What is sec-butyl? But, and there is one free valency onto the secondary carbon atom. So that is how we need to join this very carbon over here. So it would be something like this, C. So that is how the structure is. So let us just try to correlate this structure with the options that we have been given. I've got a carbon with a vinyl, with a phenyl. That means the similar carbon, the same carbon is having 3 kind of substituents attached, and also I need 1 hydrogen here. So let us just have it. Okay. So now what we observe is, we observe a bond line kind of a formula over here. Now, if you see this very compound, a carbon must be there, a central carbon must be there attached with phenyl and vinyl separately. That means having 2 valencies. 2 valencies will, one be belonging to phenyl and one belonging to vinyl. But over here if you see, this very carbon is attached with this particular group and then followed by phenyl. That is not our answer. Now if you look here, and if I try to have this very carbon attached with what? It is attached with ethyl. This carbon is attached with a group something like this or a group something like this. I don't think this is the option. Now let's move on to the next one. So what does the next one say? Okay. So if I consider here, if you look very carefully and try to match the compound that what we have here. So in here I have got 1 carbon. Let me just make a bond line formula for that. pH. That is how we are going to make it. Or I can say something like this. That is what we have. Also what? This is what we need. So let us just check. Is it so? Okay, let me just mention the methyls as well as per the question. So is it so? If you match here again, I've got what? A carbon here followed by a vinyl. Absolutely perfect. Again a phenyl, and what is this? Isobutyl. Perfect case. Over here if you see, there is no such kind of a perfection. So we have got the answer, that is C over here. C is the answer. I hope everybody is trying to correlate the structures very well. Now let's just move on. So what does the next question say? The IUPAC name of the following compound. So the compound here is kind of a complicated. It has got 3 CN groups, 3 cyano groups. Now there could be 2 possible ways for naming this compound. That means if I number this as 1, 2, 3. So the answer would be 1, 2, 3 tricyano-propane. That could be one way. But since we know that cyanide or the CN group here is terminating group, we know that this is terminating. That means we can number this carbon as 1. So I can have another way of naming 1, 2, 3, 4, 5. I need the longest possible chain. That is why I have gone to this side, not to the middle one. So what do I have here? I have got 3 cyano. This will be treated as substituent. 3 cyano. And what? It's pent, ane, pentane, 1,5 di, and what is the suffix for CN? It is nitrile. So I have got 2 possibilities over here if you observe. I have got this and I have got this. So which one is correct? This is not at all correct. Why? Because here we are not treating is in the very first name. We are treating these cyano as the substituents, not the suffixes. So I cannot use nitrile here. So out of the 2, which will be the actual IUPAC name? So if you look here very carefully, the actual IUPAC name must be going with the rules. So what does the rule say? If you've got a terminating group, you need to number it as 1 to that carbon atom. So this would be treated as the main IUPAC name, and this is nothing but a sort of common name to it. So So that is a common name, not a proper IUPAC name. So you must be very careful while choosing the options, while observing the options. So this won't be the case, but this. I hope everybody has got it. C is the answer over here. Let us just move on to the next one. Structure of the compound whose IUPAC name. Now the IUPAC name has been given and I need to find out the structure. Again I need to do what? I can have a name for this structure, then find out what will be the proper structure for that. So I have got 3-ethyl, 3-ethyl, 2-hydroxy, 4-methyl. That means these three are the substituents that I have got. Along with hex, that is the word root. 3-ene, that is there is a triple bond. 5-ine, that means a triple, there is a double bond. Oic acid means on to the first position I have got carboxylic acid. So let us just make it. I have got the word root as hex, that means 6. On to the 3, it's double bond. On to the 5, it's triple bond. So on to the 3, 1, 2, 3, it's double bond. On to the 5, 4, 5, 6. So on to the 5 I have got a triple bond. What else? On to the first carbon, it's oic acid. That means it should be COOH. Partially completed structure. Now if I look at the substituents, on to the 3, it's ethyl, 2-hydroxy and 4-methyl. So 3-ethyl, 2-hydroxy, 2-hydroxy and 4-methyl. This is what we are having. Now let us just check the options, sorry. So the option here, there must be COOH followed by a carbon which is having the hydroxy. So where is it? COOH followed by a carbon having hydroxy. That means these two options, because over here it is onto the third carbon atom and here there is no hydroxy present. So these are eliminated. Now what do I have? Out of the two I need to choose. So onto the third carbon atom I have got ene. So is it so here? 1, 2, 3. Onto the third there is no ene, but here it is. That means this is the correct option. I need not go into the detail of the molecule. D is the answer over here. Now let's just move on to the very next question. What do I have next? Sort of a typical question. It's kind of confusing as well. So what kind of a functional group do you see? It is amide. So that is amide. And if you remember the IUPAC naming of amides, you need to just number the carbon that is contained with the amide and nothing else. So all of the other things are treated as substituents. You need to number amide as number 1. So since this is a side chain, that means none will be numbered. I number this amide as 1 and this very group will be treated as substituent. This very group will be treated as substituent. That means I have got what? I have got 1 cyclohexane and I have got 1 phenyl. So what do I need? On to the first, or I can say on to the N. So N-phenyl, N-cyclohexyl, N-phenyl, N-cyclohexyl, that is it. And what? Meth for 1 carbon, methanamide. That is the answer over here. Super easy, but it seems to be confusing. So you just need to have this carbon as 1 and treat rest of the things as the substituents. So that is what you need to do, and you need to always number what? Okay. Okay, now if you see over here, what I have done here, that is a kind of a mistake over here, which is I have got 2 such options, N-phenyl, N-cyclohexyl, N-cyclohexyl, N-phenyl. What do you need to choose over here? if you look here very carefully, as per alphabetical order. So I need to check the alphabetical order in the substituents. So it will definitely be coming on the priority as compared to the phenyl. So out of the two, it seems to be confusing. D is the correct answer. I hope everybody has got it. This is a typical example of how to name an amide. So you need to practice more and more questions related to such kind of confusing functional groups. Let's just move on to the next question. Now, here I would like to give you a very important information, but just see what kind of compound they are asking. IUPAC name of this very compound may be cyclohexanone, cyclohexylmethanone, oxycyclohexene, cyclohexylidene, methanone. So which one will be correct? So if you see over here, I would like to tell you one thing about a particular group. So if you have a group something like this, here having similar kind of alkyl groups attached and a carbon which is doubly bonded. This particular group is always known as what? Alkylidene. This is always known as alkylidene. So can you see a similar kind of a scenario over here? This is nothing but alkylidene. That means I need not go into the rest of the options. I have got cyclohexylidene, that is for this very particular group, alkylidene. This entire is included, and what I am left with is this. But I need to number this carbon as one, that means meth, connected with a ketone, that means methanone. Cyclohexylidene methanone is the answer. So whenever you see such kind of an attachment having similar kinds, the two environments are similar, the two groups are similar, so these are known as always alkylidene. So you must be actually having the IUPAC name related to alkylidene. So over here it was cyclohexylidene, methanone is the answer. I hope everybody is clear about this concept. You need to remember it as it is. So let's move on to the second last question. What do we have? Now we have got the multiple choice question. So the IUPAC names, again a compound can have more than one IUPAC names. So here is the example for that. So I need to find out the IUPAC name for this very compound. So if you look very carefully, it's a pretty simple question. I've got a CH3 here and a Cl. So if you recognize, what is this? This very compound is toluene, and if I try to find out where the toluene is, it's 4-chlorotoluene. That is what we need. 1, 2, 3, 4. I will not be mentioning the para-chlorotoluene, that would be the common name. I need to number the carbons, then mention the position of chlorine. So that would be 4-chlorotoluene as the answer. Now, can I have another kind of an answer for it? Yes, definitely I can have. So if I try to number as it is 1, 2, 3, 4, or let me just have it once more. Let us just draw the structure once more. So if I treat these two as the substituents, so what will happen? I have got one methyl and I have got one chloro. That means as per the alphabetical order, I will be having chloro on the position number 1. So it would be 1, 2, 3, 4, 5, 6. That means 4 methyl I have got and 1 chloro I have got. It's 1 chloro, 4 methyl, benzene. That is the answer. That can be the another possibility of the IUPAC name. So let us just match the option. 1 methyl, 4 chloro. 1 chloro, 4 methyl. So that is the answer right here. As per the alphabetical order, chloro must come at the priority in comparison with methyl. So this option is incorrect. Also this option is incorrect. Why? They have mentioned 4-methyl chlorobenzene. That cannot be the option. So this is not the option. I hope everybody is clear with the concept. Let us just now move on to the next and the last question. Assertion reason type, type 1. We all know what type 1 is. Statement 1 is true. So you have given two statements, statement 1 and statement 2. Statement 1 is true, statement 2 is also true, and statement 2 is the correct explanation of statement 1. Statement 1 is true, again statement 2 is true, statement 2 is not the correct explanation. So I have got a correct explanation, not the correct explanation. Next is statement 1 is true and statement 2 is completely false. It is completely incorrect. And statement 1 is false, the other will be true. So these are the options we need to choose in assertion reason. So let's just move on. Okay. Statement 1 is the IUPAC name of the following compound is this. So they have given a statement that this very compound is having the IUPAC name as this. So let us just find out the IUPAC name, whether this very statement is correct or not, whether the name is correct or not. So it is, if you see at the compound, look at the compound carefully, I have got 3 double bonds and I have got 1 triple bond. So which will be on the higher priority? Will I be giving double bond a priority or a triple bond? So always remember, double bond is on the higher priority than the triple bond. That means what? I need to have this very chain as my word root. Clear? Now I need to assign the lowest possible number to the double bonds. So lowest possible number will be from either this side or that side. Let us just check where will be the lowest possible number. 1, 2, 3, 4. So I have got 1, 4, 6. 1, 4, 6. And if you number from the other side, what do you get? You get 1, 2, 3, 4, 5, 6, 7. That means I get 1, 3, 6. This is the lowest possible set. So I will be numbering from here. So that is our correct numbering. Now, what is this? Here I have got ethinyl. So that will be treated as substituent. So what will it be? 5 ethinyl onto the 5 position I have got. Hepta 136 triene. So that is the very correct option. I hope everybody has got the answer here. Now let's just check whether the statement 2 is true or false, or is it a correct explanation. While numbering the carbon chain, triple bond is given preference over the double bond. Is it correct? Not at all. Always the double bond is given preference, not the triple bond. So this statement is false. That means what option do we need to choose? So the option we need to choose here is statement 1 is true, statement 2 is false. 1 is true, 2 is false. That means C is the answer for this option. So it would be here, C is the answer. Statement 1 is true, statement 2 is false. I hope everybody has got the answer, and you need to practice lot more questions in the case of IUPAC naming. It's a kind of typical topic. Why? Because it has got so many types of arrangements of atoms leading to a complicated molecule. So you need to have a proper idea about the rules, how to actually assign the priorities, how to assign the type of functional groups, whether it is terminating or non-terminating. So that is a typical kind of a thing. We have discussed NEAT, mains as well as the advanced type exercises. You need to practice them a lot, and I'll be back in the next session with few more topics of another chapter. Till then, you just need to revise and practice what we have done so far. Have a good day.